Hey Year 7s, and welcome to Assessment 7, where we'll be doing perimeters and areas, rectangles, triangles, and angle theory. Now, if you haven't done this assessment before, first I'll take you through the questions so you can pause and work through them on your own, and then we'll take them up at the end. Here's question 1, metric conversion. Question 2, perimeters and areas of a rectangle. Question 3, perimeter, area, and metric conversion. Question 4, perimeter, area, and metric conversion again. Question 5, rearranging the area formula for a rectangle. Question 6, rearranging formulas again. This is perimeters and areas of squares. Question 7, which is angle theory. And question 8, which is parallel line and angle theory. Right, so let's start taking up this assessment. Question 1 with the metric conversion. I hope you remember your metric conversion scale. Remembering that going down the scale, for each step we multiply by 10. And when we go up the scale, for each step we divide by 10. So if we want to convert from meters to centimeters, as we do in this first question here, centimeters is 2 steps down the scale. So I'm going to multiply this by 10 twice, or just move my decimal 2 places to make this a bigger place value. So one place would make that 14, another place would make that 140. Next, kilometers to meters. From kilometers to meters, you can see that's 1, 2, 3 steps down the scale. I'm going to multiply by 10 3 times, or 10 times 10 times 10. That's 1,000. That's a 1 with 3 zeros on it, which is why we're going to move this decimal 3 places. 1, 2, and another place. Fill in the space with a 0, 240. Millimeters to centimeters, as you can see here, we're going up the scale this time. We're going 1 step up the scale, so that's dividing by 10 just once. So I just need to take off one of these zeros when I divide by 10. Next one, millimeters to meters. That's 3 steps up the scale. See, 1, 2, 3. So we're going to divide by 10 3 times, or divide by 1,000. Either way is the same thing. 3 zeros and 1,000 means we're going to move our place value 1, 2, 3 places over. So that's going to be 3.04. And our last one, centimeters to kilometers. That's a lot of steps. Let's count them. 1, 2, 3, 4, 5. 5 steps, or 100,000. That's going to be dividing by 100,000. That is 5 zeros. That's 1, 2, 3, 4, 5 places. That's in front of the 1. That's going to be 0.125 kilometers. Next, perimeter and area. We're told that a rectangle has a length of 14 meters and a width of 8.5 meters. To work out the perimeter, you have to remember that rectangles have 2 lengths and 2 widths. So the perimeter is 2L plus 2W, where the length is 14 and the width is 8.5. So that's 2 times 14 plus 2 times 8.5, which is 45 meters. Work out the area of this rectangle. Okay, remember the area of a rectangle is length times width. We are given both the length and width, so it's going to be 14 times 8.5, which is 119 meters squared. Next question. Here we're again given a rectangle. We're given a diagram this time, and we're asked to work out both the area and the perimeter. But watch out, look at the diagram carefully. I am given one length in meters and the other is in centimeters. So if I want to work out the area in meters squared, we better do some converting, and it's easiest to work with meters if we want our answer in meters squared. So when we do our area, length times width, I'm not going to do 14.8 times 287. That's 2.87 in meters. Remember, centimeters to meters, I divide by 100. So length times width is going to be 14.8 times 2.87. That's 24.476. It says we should not round our answers here, so that exact answer, 42.476 meters squared. Now, our perimeter is supposed to be measured in centimeters. It'd probably be easiest to first convert to centimeters and then calculate our perimeter. So this 14.8 meters here in centimeters is going to be times that by 100, move the decimal 2 places, 1, 2, 1,480. And remember, our perimeter is 2 lengths and 2 widths. So what I've done here is I've done my length plus my width, and then I've doubled that answer. That's 3,534 centimeters. Question 4. Again, we're looking at perimeters and areas of this rectangle. And again, look at the units of measure. If we want to work at the perimeter in centimeters, we'd better be working in centimeters. So this 0.45 meters as centimeters would be 45 centimeters. Again, meters to centimeters we times by 100. So our perimeter is 45 plus 11 plus 45 plus 11. That's adding up all of these side lengths in centimeters, which gives us 112. For part B, we want to work out the perimeter in meters. Remember, from centimeters to meters, we divide by 100, so we'll move our decimal 2 places, making this a smaller number. So shifting our place values down 2 places, this is going to be 1.12 meters. C, we need to work out the area in centimeters. Now, we've already got this converted to centimeters here. My length is 45 centimeters and my width is 11 centimeters. So 45 times 11 gives us an area of 495 centimeters. And question D, the area in meters squared. We went over this week, converting from centimeters squared to meters squared. We don't just divide by 100 as we usually would from centimeters to meters. We divide by 100 squared. When we're converting the units of two-dimensional measures, we need to divide by the scale factor squared. So we need to divide by 100 and then divide by 100 again. That's moving the place value 4 places. My decimal is here right now. I'm going to move it 1, 2, 3, 4 places. I need to fill in that extra place with a 0, and I need to put a 0 in front of my decimal. So 0.0495 meters squared. Now, if you found that complicated, you could also first convert this to meters, and that's generally the easier way for you to work it out. If you see your answer should be in meters squared, your values that you're calculating with should be in meters. So 11 centimeters is the same thing as 0.11 meters. So I can calculate my area in meters by doing 0.45 meters times 0.11 meters gives me 0.0495 meters squared. Next, question 5. We're given the area of this rectangle and we're given its length, but we don't know its width. So we're going to work out its width first by using the formula that relates to the information that we're given. So the area formula. Given that the area is 56 centimeters squared, and we know that to find an area, we do length times width. We'll start with the formula, area equals length times width, and then we'll substitute the values we know into it so that we can write an equation that can be solved. So we know the area is 56 and we know the length is 14. So we know that length times width is equal to 56, which is 14 times the width is equal to 56. To work out the width, you want to get it on its own. We want to do the opposite of multiplying by 14 to get rid of that 14. We'll divide by 14. So width equals 56 divided by 14, which is 4 centimeters. So I'll label that on there, 4 centimeters. Now the perimeter of this shape is the sum of all its outer sides. That's going to be 2 of these lengths plus 2 of these widths. So 2 times 14 plus 2 times 4. That's 28 plus 8, which is 36 centimeters. Question 6. We're given the perimeter of this square, and we want to find its area. Again, always start with the formula that relates to the values that you are given. We're given the perimeter. Let's write the perimeter formula. The perimeter, which is 340 centimeters, is the same thing as 4 times the length in a square, because all 4 lengths are the same. So 4 lengths is equal to 340. If I want to find one length, we'll do 340 divided by 4, which is 85 centimeters. Now, we are not finished. We were not asked what the length was. We've got it, but that's only going to help us to work out what we were asked for. So reread that question again. What are we working for? Work out the area. The area of a square is equal to the length times the width of that square And both the length and the width are the same thing. They're the value we just worked out, which is 85. So area is equal to 85 times 85, which is 7,225. Note that's in centimeters squared when we were originally given our perimeter in meters. That's why the very first step there was to convert to centimeters. Angle theory. Right, we are told to work out the labeled angles here. I see a bunch of triangles. Let's just focus in on A. A is inside this triangle here. 50, that square means 90, and A, those are the angles that make up the triangle. So let's start with our rule then. A plus 50 plus 90 must equal 180 because they are the interior angles of a triangle, and the interior angle sum of any triangle is always 180. So we've got an equation. We can simplify, rearrange, and solve to get A on its own. A on its own will be equal to 180 minus, now 50 plus 90 made the 140, so 180 minus 140, and that leaves A is equal to 40 degrees. So I'll label that on my diagram because that might help me in future. For question B, to find angle B, I see that angle B is inside this triangle here. B, 90, and 70 make up a triangle. So once again, I can use the rule that the angle sum of a triangle is 180. B plus 70 plus 90 equals 180. And once again, I can simplify that, get B on its own, and solve. B must be equal to 180 minus, now 70 plus 90 was 160, so that's why we're doing 180 minus 160, and B must be equal to 20. So again, I'll label my diagram because that also could be helpful in future. The next part of the question asks us to look at the whole triangle as one big triangle. So this is one side of the triangle, this is the second side of the triangle, that's the third side of the triangle. And it asks us to decide if it's a right angle triangle. Now let's look at this. Does it have any 90-degree angles? That's 40, that's 70, and that there 20 and 50, that doesn't make 90. That's not a right angle triangle. Okay, is it an equilateral triangle? Well, clearly all the angles are not the same. 70, 40, and we said that was 70. No, the angles are not the same, so it's not equilateral. Isosceles. And I'll bet a lot of you looked at this and said 70 and 40 are not the same. But what's this angle up here again? It's 70. 70 and 70, those are two angles which are equal, which means that these two sides must be equal. This is an isosceles triangle, not a scalene triangle. Scalene triangles have no sides the same and no angles the same, and here we've got two angles the same. So this is an isosceles triangle. Last question, parallel line theory, or is it? Look at these diagrams carefully and tell which one is not parallel lines with a transversal. That is, one of these diagrams shows that two lines which are not parallel with a line crossing through. So let's start by looking at A. I know these lines may look parallel, but if they were parallel lines, you'd be looking for your F, C, and Z patterns. And I'm looking at these parallel lines and I'm thinking, is that a Z pattern? If that were a Z pattern, that would mean that 125 and this question mark I put here would be alternate angles. They would be equal. Are they equal? Let's use another rule to try and figure it out. If this angle below that question mark is on the same straight line as that question mark, they should add up to a straight line. They should add up to 180 degrees. So what is that question mark? Well, to get it on its own, we'll take the 65 to the other side. It was plus on this side, so we better minus it on the other side. And the question mark would be equal to 180 minus 65, that's 115. So this is 115 degrees because it lies on a straight line with the 65 degrees. It's not the same thing as 125. So that means these angles do not sit inside a Z pattern. They are not alternate angles because alternate angles would be equal. These are not equal. This is not parallel lines. Let's check out the other ones though. Diagram B, again, it looks like these lines could be parallel. If they were parallel, I would expect to see Z, C, and F patterns here. I see a Z pattern here. meaning that this angle here, which is inside the parallel lines, but on the opposite side of the transversal, would be equal to this alternate angle here, inside the parallel lines, but on the opposite side of the transversal. They're alternate angles and they are equal. So I would say that this one, although it may not look as parallel to you as these ones, this one is parallel because they have alternate angles that follow the rules. And question C. Now 43 is definitely not the same thing as 137, but maybe they shouldn't be. Again, if these two lines are parallel, we'll be looking for F, C, or Z patterns. Now, that looks like a Z pattern, but I don't know what this question mark is. I don't know what this angle is. I do know that it lies on a straight line with that 137 though. So that question mark and that 137 should add to 180. Now get that question mark on its own, find out what that angle is. What adds with 137 to make 180? Easiest, do 180, take away that 137, and see what's left over. It's 43. So my question mark is 43 degrees. They must be alternate angles. They are the same. Those must be parallel lines because they follow the rules. So which one does not follow the rules? Well, that was the first one we saw there. Diagram A is not a set of parallel lines with a transversal because this alternate angle or this Z pattern doesn't fit the rule. So I hope you guys found that helpful, and please let me know if you still have any doubts.